Thank you very much for joining me today. In part 1, we went over the introduction to building the USB HID/PID flight simulator hardware interface on the STM32H723 series microprocessor. In this video, part 2, we'll continue with configuring the microcontroller. I'll start with some prerequisite tools, software, and documentation that you will need. To configure the microcontroller, we'll be using the STM32CubeMX tool. As you can see on the screen, this is the ST website. You can download the tool. It's a free tool from ST, and this will do the initialization code. The link for this tool and the other tools I'll mention will be listed in the description. For more information on the microcontroller, remember to visit the ST website, and on the ST website you can find information on the STM32H723ZG series, and that is what's showing on the screen right now. So please go ahead and visit it and you'll find more details. The board is available on Amazon for $19.99, $20. So you can get it there, and it is by EC buying. For the code development, I'm using the IDE provided by ST, and that is the STM32Cube IDE. And with that, after it generates code, you can go ahead and continue your modification and development within the ST family. So I think it's a great tool. That's what I use. You don't have to use it, and even when you configure your microcontroller, you can specify the format you want, and I choose the STM32Cube IDE. In addition to the IDE software, you're going to need the ST Programmer software. This software will program the hardware that you would use. It's a USB dongle that connects to the board, so you can program it. So go ahead and get one of those dongles. I'll show you the link in a little bit, but you also want to get the software too. So go ahead and get that too. The dongle is available on Amazon, and you can get it for $5.99. So there are other ones that are available, but I'm just showing you one option that you can use, and it's available on Amazon. So go ahead and get one. You'll need that one. For reference, or if you're into microcontroller programming, I highly suggest you get this book. This is the Embedded Systems with Arm Cortex-M microcontrollers, and this is an assembly language in C. I tell you, this is a very good tool, and it will go over, if you want to, if you're the type of person who would love to build your own drivers or to start programming from scratch, this will be the book for you. It will take you from beginning all the way up to be able to program the microcontroller, get it up and running, and you can write your own code, whether you want to do it in assembly or C. This is a great tool. So please check out this book on Amazon, and this is the 3rd edition, but I think the latest edition is the 4th edition now. Additional reference tools are available for download on the ST website or within the STCubeMX tool. So go ahead and download it. We're going to use this application notes. This will go over how to configure the timer settings and other features, especially the encoder. There's a special section how to configure the quadrature encoder, and we'll go back over this in a little bit. Let's go ahead and get started with programming the microcontroller or configuring the microcontroller. So we have the tool, and we're going to go ahead and start my project from MCU, and then from here we can go ahead and select the microprocessor we're working with, and we'll just go ahead and do that. Once you have the program loaded, you can go ahead and search for the microprocessor that you're using or you will be using. So let's go ahead and do that. Simply go ahead and just enter the part number or the first part of it, and it should pop up. Or you can search. So that's what we're going to do. Enter some part of the number or most of it, and then you should see it in the list on the right. And once you select it from the list, then you can now access the tools and information about the part number. You'll see the overview information about the microprocessor just like if you were on the website. And there are tabs at the top for the block diagram, docs, and resources. We can scroll a little bit, but if you look at the top, you can also access quite a few tabs. The block diagram, and you can scroll and look at the features just like we were doing on the website, and has quite a bit of features. On the Docs and Resources tab, you have access to a lot of documentation from within the tool itself, so you don't have to search for it anywhere else. All the ST documentation, or I should say most of it, relevant to the microprocessor are in this section. In the CAD Resources tab, you will get access to all the CAD files. So if you're into circuit design, you can get the CAD files, the symbols, footprint, and the 3D rendering as well. So if you do circuit board design in KiCad or in Altium, this is a great resource that you can load into the environments, whether it's for KiCad or Altium, and you can render the board as you're designing your board. Now we can start the project by clicking the Start Project button, and we'll go ahead and click Yes. Once you're in the program, you can actually zoom around and look at the pin layout of the microprocessor or microcontroller, and from here you will be able to go ahead and start assigning the functionality for the pins that you want to choose. We'll go ahead and configure the GPIO, and we're going to select a few pins that we're already familiar with, especially on the expansion board that I designed. I'm going to enable pins for the buttons that we already know, 4 buttons, including one of the encoder knobs, and the 2 encoder timers. And in addition to that, we'll go ahead and set up another timer. It will be an update timer, and we'll go over that some more. And so let's go ahead and get this going. The first pin we're going to configure is PD15, and that is going to be the button associated with the encoder 1 knob that we'll be using. The other pins we'll be using are PF8, PD11, PF6, and PF7, and those will be associated with buttons. Please note also that when we are selecting the pins, at least these button pins that we've been selecting, we're using the GPIO EXTI, so therefore they will be interrupt pins. So like the next one we just did is the EXTI11, and we're going to do the PF6, and that one is GPIO _ EXTI6. So that means that it's an interrupt, or external interrupt. And we're going to do the same thing for pin 7. And if you see the board that's showing, that's the encoder 1, and that's the top encoder, and the bottom encoder, that's a dual encoder knob. So you can see at the bottom, that's the encoder, the button is on the top, and we have these 4 buttons here, the green, and the button for the encoder, and the green button, and those are the 4 buttons that we'll be using right there. We'll continue now to assign PF7 pin, and again we're going to put it as a GPIO interrupt, so GPIO EXT7 I7. So those pins are assigned. Now we'll move on to configuring the pins. So the pins, we want to make sure that because we're using them as buttons, when we press down, we're going to move from a high voltage to a low voltage. So we want to change it to our falling edge trigger detection. So that's the external interrupt mode that we want to choose. And then we want to do a pull up. We want to add a pull up resistor. So that we're going to, if you could see right now, there's no pull up or no pull down. So with the pull up, that will allow it to be high by default, and then when you press down it will be active. And we're going to do that for the rest. Now in the NVIC tab, we'll go ahead and enable the interrupts. If you notice, there are 2 interrupts currently. Those handles the 9 till 5, so pins 5 till 9, and then pins 10 to 15. For every pin you assign, the number must be unique up to pin 0 to pin 15. So you cannot have conflicting pins. If you look, 11, 15, 6, 7, and 8 are unique. Next, we'll go ahead and enable the interrupt. Next, we'll move on to configuring the clock. We're going to select the high-speed clock, and we're going to select crystal ceramic resonator, and later on we want to come back and enable the sync. The option we want is the USB HS, and that will be available after we enable the USB. Our microcontroller can go up to 550 megahertz, and this time I just want to go ahead and configure it for the max right now. Here I will go ahead and enter 550 megahertz and then hit enter, and it will start the configuration. And the clock did make some changes. I'm still going to have to go ahead and make some correction for my own satisfaction based on what we want. But at least for now, it has it configured to this point. One thing I need to do is change the frequency to the HSI. So I just did that to connect to the 25 megahertz external oscillator. So that's one of the things I definitely wanted to do. So we're going to go ahead and reconfigure it with that setting, and a few things should change. We're going to go back and change the max frequency and hit enter again. Then it will resolve the clock issues. Now we want to check a few things to see if it is configured to our requirement. As we include the additional settings for the ADC and for the not for the encoder, but for the update timers, then we'll have to come back and make the other changes here. When we actually make the changes for the USB, we'll come back and set the CRS sync and select the USB HS for that. Next, we'll select the RCC global interrupt to enable that. Now we'll move on to the ADC settings. The ADC, again, I mentioned earlier that we'll use that for the variable potentiometer or the variable resistor. So we're going to use pin PF9, and then we're going to enable the ADC for that. You notice it's in yellow. Certain times, this means that you cannot use the full capacity of the ADC. It is being used by some other resource. So maybe another pin is using some of it, but it will still work for what we need. Notice that the configuration is highlighted in yellow. We just need to go into the input to and select a single-ended mode, and that should resolve it. By default, the ADC frequency will be too fast, so too high. So we're going to have to go ahead and change it. We can go ahead and resolve this issue here. It should automatically do it, but once we scroll down, the ADC frequency is at 100. We need it to be around 20 megahertz for what we need. So we're going to go ahead and make some changes to fix that. Changing the frequency here, if I go ahead and put 20, hit enter, it will go ahead and resolve it, but it's going to make some changes that will not be comparable. So if we scroll back up, we'll see that the clock is not at its maximum anymore. So we have to play around and make the changes to correct that actually within the block that is shown right here. So let's go ahead and do that. For my previous setting, I'm going to go ahead and select 40 here. And then from here, after we do that, we will also divide by 25. So we'll target around 20 megahertz, and we'll go ahead and check. It should propagate down to the ADC clock for 20 megahertz. So now it's at 20, so that's what we need. Now we're going to go ahead and change the setting here so we can resolve the clock. And I think 45 multiplied by 45 will resolve it here. So that is taken care of right here. I actually meant 44. So multiply by 44. Depending on the microcontroller you're using, the frequency and values will be different, at least for the configuration. So just so you know that. Then we're going to select the asynchronous clock mode and divide by 10 in both for the prescaler section. So I don't know why they're two prescaler, but yep. We're also going to change the ADC to 10-bit because we're counting up to 1023, or so 124 different combinations with that 10-bit resolution. So it's going to be more than 8 bytes. We're going to use right alignment, and we're going to go ahead and set up the DMA later. We need to set up the DMA, so that way we'll select ADC from here. We'll come back to this, but we need to change it to circular and half word, because it's more than 8 bits. We need to at least go up one more to half word. It won't fit for in 1 byte. And I think that's it. Well, we already we're dividing by 10, so yep. And then 8 bits. We were not using 8 bits. We're using 10-bit resolution. So as I mentioned, so that should be it here. Under the DMA tab, we need to make a small change. We need to make sure that we're using the stream instead of the DMA channel. So we're going to use stream DMA1 stream 0, and it's the peripheral to memory. And yep, low priority. And that should be it. Oh, we need to enable continuous conversion mode and DMA continuous request. We want to also do DMA circular mode. Next, we want to enable the interrupt, so the ADC global interrupt. We're going to enable that. Now we'll go ahead and configure the timers. We're going to start with timer 2. But I want to show you something. This is the application note AN4013. This is a document provided by ST, and it goes over the configuration for timers. So it covers the quadrature encoder settings. In section 4.3.4, yes, section 4.3.4, it goes over the encoder modes. And this, with the quadrature encoder, you can see there are 2 signals for the encoder pins coming off an encoder. So when it is leading, when T2 is leading, it's going forward, and when T1 is leading, it's going backward. So as you go backward, T1 will lead, and as you go forward, T2 will lead. So it will determine if you're going up and down. We'll look at another document by Burns, and this will go over the schematics. They do include some options you can use for debouncing. Every time you press or turn the encoder, it can make multiple firings, so it will give you incorrect values. So there's a circuit that you can use here. One is if you wanted to get the microchip, the MC14490, that is a built-in debounce, and then you can use your decode logic. On the other hand, you can use the noise filter circuit. You can use a capacitor and a resistor for the debouncing, but if you have to put more or additional equipment or additional parts in your design, it will increase costs and complexity. So actually what I did it in software. Actually in the configuration, I can show you where I did that, at least for the debounce. So I only included a 10 ohm pull-up resistor for the encoder. If you can look in figure 2, I did not include the capacitor and the 10k ohm debounce. I just included the pull-up the 10k pull-up resistors on each channel. So we'll discuss some more about the debounce once we're doing the configuration of the microcontroller. Again, the document I'm using is Burns. It's from Burns, and they make encoders, so go ahead and look through the options that they have. They have quite a few selection. We'll start with the encoder configurations. I'll use timer 2 and timer 3 for one of the knobs on my board. So with that, that will take care of the knob for the channel 1 and 2. There are 2 channels on that encoder. And additionally, there's some additional encoders you can use here. 4, 3, 4, and 5 are perfect for encoders. 8, timer 8 as well, and timer 23 and 24. You can use timer 1, but it's an advanced timer, and I reserve that if I need some more advanced functionality, then we can use that later. Timer 1 is special, I would say. So we can move forward with that. Timer 15 I'll configure, and that is an update timer. And instead of using a while loop to poll, it's best to actually use an update timer. So that way you're not tying up resources, and you can update or send your HID signal, USB HID signal on a timed event. So it can do it every like millisecond or 5 millisecond based on the speed that you want. So let's go to do the configurations now. In the top section on timer 2, we'll scroll down a little bit so you can see the combined channels. We're gonna select from there and make sure we select encoder mode. So once we select encoder mode, it will show you the pins that are being assigned. But we are going to change those because I had reserved for encoder 1 knob that I want. It was already using 2 other pins, so I'll show you how to go ahead and change that. By default, you can see it selected PA0 and PA1 for timer 2, and we're going to change it to the pins here. And I want to use PA15. That will be used for channel 1 on timer 2. So if you look in the list, you'll see timer 2, channel 1. So we'll select that, and that automatically reassigned channel 1. And if you look, it's no longer selected here. PA0 is no longer selected. And then we're going to select the other pin that we're using, and that will be PB3, I think. Yes. And we're going to select timer 2, channel 2. And there it is. And if you look, it actually reassigned those pins. So that's how you would reassign a pin for the timer if you wanted to select a specific pin that is compatible with the timer you're choosing. In the settings, under the parameter settings, we're going to change the counter. Of course, counter mode is up, and we're going to change the value to 255. Yep, so then we're going to go ahead and do a division by 2. Then for the trigger event selection, we're going to put update event. So we want this to update every time we're changing the value as it counts. We want to update the event. So we want to call a callback function that will use ERC logic to determine if we're counting up or down. For the encoder mode, we're going to use encoder mode TI1, then we're not going to do any division. It's still rising edge, but we're going to change the input filter. This is where I mentioned we will, in the configuration, use it to fix the debounce. And 15 works really well. That's trial and error, and it worked well for me. So that's what I did to address the debouncing. So you do the same here, rising edge, and then we're going to, for channel 2, rising edge, of course, then no division, and we're going to go ahead and change it to 15. Next, we're going to go ahead and enable the global interrupt. So we'll check that, and we are not using DMA, and GPIO is already configured automatically for what we want. So that should be it for timer 2, and then we'll do the same for timer 3. Yep. Now that that's done, we're going to go ahead and enable the interrupt, and then we're going to select that. We don't have any DMA, and the GPIO is already set up as is, so that's it. Next, we'll do timer 15, and timer 15, it's a basic timer, and we're going to go ahead and use that to generate the update event. So based on how we configure it, for every, let's say, millisecond, based on the values we determine, it will continually send a signal, or not a signal, it will send the HID descriptor information. So we're here on the, timer 15, and I chose timer 15 because it is a basic timer. It doesn't require a lot of resources, and for other timers that are more complicated or complex, can do complex or more, I would say for other advanced timers, I left them or reserve them if I'm not using it. But in this case, I don't need to use the advanced timer. I just need a basic timer. So I use timer 15. We're going to configure the internal clock on this one. So, and if you look at the clock, this is important. APB1 timer clocks is at 275 megahertz, and the AB2 timer is at 275 megahertz. So based on that, we're going to configure this to use a prescaler, and for the value I needed, for right now, I'll go over the calculation I used later, but I'm going to use for now for 2,750, and I'm going to minus 1. And then for likewise, I'm going to just do 100, changes to 100, minus 1. And because 1 will be added later during the calculation, so you want a minus 1 in these cases. The next thing, you don't want to reset here. I do want to update event. Okay, so we're going to use the triggered event selection for update event. Once we do that, we are going to go over to the NVIC, and we're going to go ahead and enable the global interrupt or the timer. So we just enabled that interrupt or timer 15 global interrupt. And let's just double check. We don't need DMA. And that's all we need here for the timer. And the next thing we're going to enable now that we enabled the timer, so let's just do a quick recap. In the core, we enabled the clock, and we're going to go ahead and use the USB to sync. We did the GPIO, and as we were going along, we enabled the DMA and also the NVIC interrupt. So those were done as we were making the ADC and also the timer changes earlier and the GPIO. So let's go down to connectivity. So under connectivity, you're going to go down to USB. And under the USB, we're going to enable device only. That's all we're going to use. Device only for USB. We're going to use full speed and 12 megabytes, actually megabits per second. That's way than enough for what we need. And that's all we need here. We don't need to do anything else. We just want to check a few things. And yes, we do want to enable a global interrupt and the other interrupt settings here. And that's all we need here. So now with that done, we're going to go down to the middleware. And in the middleware, you're going to see the USB device. So for the USB device, we're going to go ahead and select Custom Human Interface Device. We do this because if we were to select the human interface device alone, every time you make changes to your code or generate changes, it will cause a problem. And if you notice right now, something changed in the clock configuration. So we're going to have to go ahead and fix that. So let's go ahead and allow it to automatically fix it first, just to make sure. All right. So it finally adjusted. And if you look here, it's showing 48, the frequency for 48 megahertz. I know that's not the one I want to use. I want to use the HSI value, so I'm going to make a change to that. So let's go ahead and change that to the HSI, and let's go up. Yep, that's the value we wanted to use. So perfect. So let's just check. I just wanted to check a few things on the clock that sometimes it will change, and don't like it when it changes the settings that I had from before. Yeah, that doesn't work for me. So here again, it went back over and changed. I want this to go down to 2, and I want to do 44. Do 75. And I'll fix this. This was at 40 before. And we were dividing by 25. Okay, and this gives us our 20. And for here, let's leave this at 2, 24. Just going to divide that by 5 to match future settings that I need. So if I look here now, everything, I need 48 megahertz here, and for my ADC I need 20. So clock looks right now. Everything else should be fine. Okay, so let's go back over here. All right, so if you notice the vendor ID and product ID, these are actually correlating to STM electronics, and they do have on their website an option for you to get vendor a free based or reduced price product ID based on and using their vendor ID. So you can check that out. I'll provide it at a later time, but for right now, you can change this. I changed this to just for my own use, just for now, Molinga, but just for testing only. What I changed this to was my PFD and MFD. Yep. This details right here. The next thing, if I go back here, I want to make sure that this is 5 for my setting for the HID descriptor. It's 0x68 and 0x14. So that's going to be the size of your, the total length for your report descriptor in endpoint, and the maximum report buffer size out endpoint. So that is it. You don't need to change anything else right here. But under here, we already made the changes. And here, let's just go ahead and save right now. And that's all you need right now until anything else pops out. So all the other pins have been configured based on what we selected. For the USB, I just want to double check something else, because yep, everything else is configured, but there's one thing I need to make sure of here. We're using custom. That's good. Okay, so there's one thing we had to go back and do. When we were configuring the clock, we needed to make sure we were syncing with the USB high speed. All right. So that's it. There's something here that looks a little bit strange because I didn't need to have the additional pins. Because we didn't select OTG, and that's some of the things that happens with this configuration tool. It will give you, got you, kind of a configuration. While it wasn't showing up on my other configurations, it will sometimes show up here. So that's what I'm just making sure. Okay, I just figured out the issue. I just figured it out. If you look here, I'm selecting it from here. I should disable it because I'm activating external physical interface. I don't want to do it from there. And this is a really sneaky gotcha moment that will cause a lot of problems for you down the road. And it did for me. So instead of enabling the external physical, you want to disable it. Then in the internal, that's where you choose device only, and that will fix the issue. So if you look, none of the other extra pins were not generated here. It removed them. You only need, for the USB, it's only going to give you 2 pins that you need here. That's it. So that will cause you a lot of problems. So please be careful when you select this. Make sure you use the internal full speed, not the external. Do not select the external, and that will be so. So let's go back and re-enable these, and from there, let's double check again. Once you make changes, you might want to double check to make sure it's consistent. Right. So you'll have to go ahead and reselect this. It will still save your previous setting, but you just want to make sure you have it selected. So that was the part I wanted to make sure I had it covered. And going back here, I want to make sure sync is back to just perfect. ADC, notice we don't have those conflicts anymore. So I think we're good. We're in a good state. All right. Save. We'll just double check the clock configuration. And everything seems to be correct. Let's go to the Project Manager tab under Code Generator. And you're going to copy only the necessary libraries. Only the necessary libraries. And you're going to back up. I always choose backup previous files or generated files when regenerating. And these are the only ones you need to check right now. And advanced, shouldn't have to do anything here. Don't forget to go to the project and also select your toolchain IDE. And just to look, yep, those are the only pins we're going to select. Just to go over one more thing. In the timers, I had 7 encoders. So here I'm only showing you 2 encoders. And I had 2, 3, 4, 5 are set up for encoders. And I'm going to show you the rest. And then if you go to 8 is a can work with encoders. And 23 and 24, 1 can, but I didn't want to use 1 because it's advanced timer, and I would rather leave it for things that need it later. Let's go ahead and generate the code. Okay, it will give you 2 options: open the folder or open the project. I like to go ahead and open a project. I mean, in this case, and now it will open the IDE. Says successful. I'm going to close a previous project I was using, so just close that project real quick. Actually, let's just go ahead and select this close project. And here you have it. If you look here, you'll see the structure. You'll see your includes in main. It generated the main file for you. And it gave you a structure. It configured your GPIO, DMA, ADC timers, and your USB initialization. So those are perfect for now. In the next video, we'll go over the code changes to get the microprocessor up and running, and then we'll continue from there with the HID setup. Thank you very much, and please support the channel. Have a good one.